All right, here we go with term 3. So here we are going to be graphing different types of functions. So this right here is going to be a linear function. The way I know that is because the variable x is to the power of 1. So what this tells me is that my line is going to be a straight line, either up or down. So I'm going to use these inputs right here, -2, -1, 0, 1, and 2. And what that means is I'm going to put these into the equation, and then that's going to give me my ordered pair that I'm going to put on the graph. So if I plug -2 into here, 3 times -2 is -6. -6 minus 5 is -11. Oh my goodness, this point is like all the way down here. So here's -2, 5, 6, 7, 8, 9, 10, 11. Holy cow, that's like all the way off the screen. Okay, let's plug in -1. 3 times -1 is -3. -3 minus 5 is -8. Okay, so again, off my graph, but whatevs, YOLO. So -1 is at -8. So -1, 5, 6, 7, 8. All right, there we go. If I plug in 0, 3 times 0 is 0, and 0 minus 5 is -5. There we go. That's another point right there. If I plug in 1, I get 3 times 1 is 1, and 3 minus 5 is -2. So my next point is going to be at 1, -2. Sorry, buddy, I'm covering you up. 2, if I plug 2 in, 3 times 2 is 6, and 6 minus 5 is +1. So I'm going to go to 1, 2, and then up 1, +1. And now what I'm going to do is I'm going to connect my points. Ooh, I wish I had a ruler. I didn't grab a ruler before I was quarantined. Wha-bam. Oh, look at that. It is long, it is lean, it is beautiful, it is kind of straight. So that is my line for my linear function. Let's go down to this guy right here. Now, this is an example of what we call a quadratic function. A quadratic function, I know it's a quadratic function because my x is to the second power. And what that means is my graph is going to be a parabola shape. So it's either going to be like that or like that, a smile or a frown. So what we're going to do is we're going to use the same inputs. You probably remember using these. So when I plug in -2, that's -2 to the second power. So -2 times -2 is +4. And 4 plus 1 is 5. So -2, +5, right there. If I plug in -1, -1 times -1 is +1. So 1 plus 1 is 2. So my next point is going to be at -1, +2. Okay, I love 0. It's so easy to work with. 0 times 0 is 0, and 0 plus 1 is 1. So what this means is that my x value is going to be 0 and my y value is going to be 1, just like that. All right, so 1 times 1 is 1. 1 plus 1 is 2. So now I'm working on the other side, just like that. And then 2 times 2 is 4, and 4 plus 1 is 5. So if you remember with quadratic functions, there's kind of like a mirror effect. So you see 5, 2, 1, 2, 5. So that means my last point is going to be at 2, 5. And when I connect these points, lovely. That is what your quadratic function looks like. All right. Last but not least, when it comes to graphing our functions, we have this, which is called a cubic function. A cubic function, I can tell, is the x is to the third power, or it's x cubed. So I'm going to do the same thing. Oh, also, these graphs look like giraffe necks. Whoa. Or really terrible lightning bolts. So I'm going to use my same inputs once more. When I plug in -2, that's -2 times -2 times -2, which is not, I repeat, not -6. It's actually -8. So -8 minus 2 is -10. So I've got -2. Oh, brother, I didn't label these. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my God, I'm all the way into the next problem, 10. Okay, all the way down there. That's my first point. -1 to the third power is -1. And -1 minus 2 is -3. So my next point is going to be at -1, 1, 2, down 3. All right, that's a point I can see on my graph. Oh, 0, you're so fab. When I plug 0 in, 0 to the third power is 0, and 0 minus 2 is -2. So that means 0, -2, just like that. Okay, when I plug 1 in, x to the third power. Okay, so 1. 1 times 1 times 1 is 1. 1 minus 2 is -1. So my next point is going to be at 1, -1. And then when I plug 2 in, 2 to the third power, 2 times 2 times 2 is 8. 8 minus 2 is 6. So you'll see there's no pattern here with cubic functions. So 2, and then I'm going to go up 6. 1, 2, 3, 4, 5, 6. Just like that. Okay, so you can't see this little point all the way down here, but when I connect these, oh boy, trying to make it as giraffe-y as possible. It's pretty terrible, but that's what a cubic function looks like. All right, moving to slope formula, my friends, please memorize this. y2 minus y1 over x2 minus x1. That is your slope formula. That describes rise over run, how your line is changing on the y-axis, that goes up and down, and how your line is changing on the on the x-axis, which goes from side to side. So x, y, x, y. It does not matter which one you choose as x1, y1, and x2, x2, or y2. It really doesn't matter. What I like to do is I just keep it all in, I just go do, 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 do. I've also seen people using arrows, super helpful to do that. So I'm going to subtract -6 minus 5 over -2 minus 4. 2 minus 4. So I've got -6 minus 5, which is -11, and -2 minus 4 is -6. When I've got two negatives, it makes it positive. So the slope for this first problem in your study guide is +11 over 6. And we write it just like that. It's a ratio. We're not going to turn it into a mixed number. What that means is your line is going up 11 over 6, up 11 over 6. All right, let's do this one. I'm going to use this arrow method because that is just awesome. So 5 minus 8, 5 minus 8 over 3 minus 3. So 5 minus 8 is -3, and 3 minus 3 is 0. Now here we go. This is a no-no. This is a no, 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 no. We cannot have zeros in the denominator. What this means is that there is no slope. What this means is that your graph is boom, like walking into a wall. That's what your line looks like, okay? So when you have 0 as your run, is no slope. No slope. All right, let's go to the next one. 1 minus 1, 6 minus -4. So 1 minus 1, 6 minus -4. 1 minus 1 is 0. 6 minus -4 is 10. Okay, so now we have a different situation where there's a 0 on the top. This means that your line is not going up or down. What this means is that your line is completely flat. And what this means is that your slope is 0. You can write it like that, or you can write it like that. Your slope is 0 when you have a 0 as your numerator, okay? Okay, one last one. 2 minus 4 over 5 minus 9. All right, so 2 minus 4 is -2. 5 minus 9 is -4. So a negative and a negative becomes positive, 2 over 4. Now remember, this is a ratio, so we are writing our ratios in simplest form. So the slope is 1 over 2. Okay, that's it for slope. All right, moving on to square roots and Pythagorean theorem stuffs. Okay, you need to just know these. So the square root of 169 is 13. The square root of 400 is 20. 17 squared, oof. What is 17 squared? I gotta come back to that, I forgot. What is 19 squared? I think it's 3. You guys, I don't know what these are. I'm gonna have to cheat and look it up on the internet. This is how ill prepared I am. Anyhow, how's everyone's day going? Oh, great. This is great. Oh my gosh. 17 times 17 is 289. Thank you, Google Calculator. And 19 times 19 is 361. Okay, I was close. I was gonna say 381. Okay, so let's look at this last one right here because I bet a lot of people were confused. Well, guess what? You can have a square root of a fraction because you can take the square root of 4 and you can take the square root of 25. Your answer is gonna be a fraction. So what is the square root of 4? It's 2. And what's the square root of 25? It's 5. Ta-da! That is your answer. Oh my goodness. I think we should stop at term 3 and I'll do a separate video for term 4 because this is a lot. This video is almost 12 minutes already. Okay, finding the missing side lengths. This is the Pythagorean theorem. A squared plus b squared equals c squared, where c is your hypotenuse. Okay, so we're going to use squares and square roots to figure out this, the missing sides. So here, one of the legs is missing. So we've got x squared plus 6 squared equals 10 squared. And remember, we can only use this with right triangles. So I'm going to clean this up. I'm going to simplify my exponents. So 6 squared is 36 and 10 squared is 100. I'm going to subtract 36 from both sides. I'm gonna write, okay, my answer over here, well, 100 minus 36 is 64. Good mental mathing. Now, I need to figure out what number, when you square it, gives you 64. So, you can take the square root, and the square root of 64 is 8. So here, the missing side length is 8. All right. We come over to this one. We are given both of the leg measurements. This time we're missing the hypotenuse. So over here, we would set up our equation 5 squared plus 12 squared equals, let's make that question mark an x squared. Okay, so 5 squared is 25 and 12 squared is 144, and that equals x squared. So 25 plus 144 equals 169. So I need to find out what number, when you square it, gives you 169. So square root of 169. This is why it's helpful to know these things. And when you find the square root, it's 13. So that missing side length is 13. Okay, term 4 is going to be in a separate video.